Hello everyone, welcome to my channel Cryptoware. So in the previous video we did some analysis on the Locky ransomware and today we are moving ahead with it. So there are some very interesting observations that also I would like to share while doing this analysis and also, let's recall what we had observed last time. I'll share the video, I mean, the link of that video of the part one in the description below so you can go through it. So, in the previous video, in the last video, we saw that it replicated itself and renamed itself to svchost.exe. Two reasons: one is to gain persistence, and second, that we will see the name getting executed as svchost.exe. So we may not be aware that this is the malicious one or this is a genuine one. So this could be one of the reason. So we'll start with this analysis only. We'll start analyzing the sample only. So we'll open it in x32 debugger and we'll see some things. For example, we'll search for some strings if there is anything interesting. So there's nothing interesting as of now, but that is fine. And we have already set some breakpoints to basic virtual alloc, virtual protect, whatever will be required. So we'll see that as well. So let's run. Okay. And it uh, so the breakpoint is hit, which is virtual alloc, and we'll click on execute till return. And virtual alloc is supposed to keep the address where the memory has been allocated in the EAX register. We have discussed about this in our previous videos as well. So we'll follow it in dump and we'll click on next, and we'll see that yes, something got allocated over here, but we'll keep moving forward and let's see what happens next. It's kind of slow. Meanwhile, we can check. Yes. So how will you identify that this is not the original SVC host? We discussed right last time that it's unverified. So no problem. So here we see the virtual protect is there. So virtual protect is mostly used to change the permission. So it is trying to make it executable. So that is fine. We'll move ahead. There's another virtual alloc. We'll follow the same process and we will right click and follow it in dump 2 this time. And let's click on run. And here we see an MZ file, which is interesting. So let's dump it into the follow it in memory map and then we'll dump it. So here it is, and this is right now RW, but like the previous thing that we had observed, similar to that, I'm expecting it to change its permission to executable through virtual protect, but we are not going to wait for that for now. But I'll dump this memory to file. See host, and I'll dump it in desktop. Okay. And here, yes, you can see that it has reached to virtual protect. So I think we let us analyze this sample which we have dropped just now. Um, this is the one. I don't want to confuse, and I'll copy it just in case. So before that, we'll see in P Studio certain things. Um, so for example, with SVC host, why I want to see the SVC host, I want to see the entropy. Although the entropy is not more than 7, but still we saw that a lot of things were not visible, which is fine. It is not very heavily packed, so you can actually unpack it manually. And this time we are going to see the one which we have taken from here. So it is less than 6. And let's see what virus total says, that it is Locky. So it is also the ransomware. So maybe this is the unpacked one. And if we open this in X32, and if we right click search for all user modules and string references, here we are going to see some interesting things related to the ransomware, like Locky recover underscore instructions dot txt. So we'll set a breakpoint over here. We'll set a breakpoint over here as well, which is act equal to stats. Whichever thing that we are finding it very interesting, we'll set a breakpoint to that part. Act get key. This makes me feel that it is trying to make a network connection. So we have Locky recover instructions.txt .bmp. So it's quite interesting. As I mentioned that here is the IP, so most probably it is trying to make a connection to that IP. Here's SVC host also. There's public key mentioned over here. We'll set a breakpoint to all of this because we are going to see everything, and we can see that it is mostly it is using this path. So I think this is for again gaining persistence, and after the system gets rebooted, this encryption process will keep going on. I mean, the ransomware will execute itself. So I think this should be enough for us for now. um so let's see. We'll click on this, and let's see, let's remove P Studio. We can close this, and we can see this. Another thing that we can see is procmon. So let's select process name. Okay, we cannot see the process name. No problem. Looks like there's some problem. It's not running. I'll do one thing. Let's try resetting. Process name. Can I see? Yes, cool. So the process name is SVC host. This one. Apply. Okay. Okay. So let's keep going. We'll ignore that. Okay. So it looks like it executed, or maybe it it has it has identified a debugger, so it has closed itself. But we see a lot of things over here in the registry. Now, if you see, I'm not very much bothered about the fact that it got executed or it is going to, perform the encryption, the process of encryption. That is what I want to discuss. So I'm not putting too much efforts into identifying that from there, because this tool itself should be able to. So Locky ransomware, along with there are I think other ransomwares also. Locky ransomware is quite old, and I think this is one of the very older version of ransomware. So the Locky ransomware basically tries to make a connection with the C2 server. So we did see that 86 dot something. Let's see. Okay. It has actually terminated itself, and it has created a copy of itself, which is here, 96 kb. This is the one. This is the unpacked one. So we can directly open this one only. Yes, the breakpoints are already there, and because I have analyzed this before as well. There are a number of things that I would like to discuss about. So this is already unpacked. So I'll just keep putting breakpoints to these also while explaining everything. Few things that I wanted to discuss as well are like PEB, which is process environment block, and TEB, which is thread environment block. But I think that I should be discussing it in a different malware context where it is actually working or doing something. I mean the malware. In case of Locky, I don't see the malware is functioning very um, the way it is supposed to work, because you can see that everything is already written over here, present over here, and it is sorry. So everything is written over here already. I think I have to set the breakpoints again. No problem. So we'll just put some few breakpoints and we'll. So Locky always tries to connect to the C2 server first before performing or before starting the encryption. So basically, what it does is, apart from the IP that you observed or we saw it over there, it also follows domain generation algorithm as well. So it only is able to perform the process of encryption after it is able to make a connection to the C2 server. As a result, after doing a lot of analysis with this thing, I realized that yes, it is not able to perform the encryption because I tried all different ways. So even if you shut the internet and suppose the C2 server is active, until and unless it is able to connect to the server, it will not be able to perform the encryption. So we'll move on to some other ransomware samples which are not dependent on their C2 server for encryption. So basically, they'll be performing their encryption before itself. So here I tried showing you how I'm able to unpack a very small part of unpacking. The process of unpacking it follows. It is not out of the blue, something that is going to take a lot of time. But yes, here after unpacking, we did see those texts which are actually present in ransomware sample. So most probably, I'll be coming with an analysis of a ransomware sample which actually gets executed and which performs the encryption so that I can show how the encryption happens. But meanwhile, I can try showing you that how it is trying to connect to the server. So here, if it is possible, we'll see that it is trying to connect. So you can see that it wants to send some data. Why am I saying that? Because in the strings section, you would have seen string references. These are certain things that it is trying to share. Okay, so basically, it is related to the RSA key, which needs to be generated at the server end as well. Without that, it will not be possible for Locky to perform the encryption. That is what I have actually understood from my analysis. So so you can see that some cryptographic algorithms are there, like functionalities are happening, not algorithms. Wrong choice of word. So it is performing some sort of cryptographic things that it is supposed to, but ultimately, as you can see, it is not able to share the data. If you keep going, this is what it is supposed to share with the C2 server. As a result, it is not able to share it with the C2 server. These are all cryptographic algorithms, like related to cryptographic activities. System function 32. You can see this bcrypt primitives. Even in the part 1 of our video, we saw that how we could see all the DLL and function calls. So that's how. So you'll see certain things, some IPs or some, here is that HTTP connection. So you'll see certain things get generated. So most probably it is trying to follow DGA, domain generation algorithm. I'm not going to explain that thing right now, but yeah. So that is how overall this Locky ransomware works. I'm extremely sorry because this Locky ransomware sample is a bit old and it does not start the process of encryption unless it is able to connect to the C2 server. But I'll quickly come up with a new video where I can show you the process of encryption with some other ransomware samples, some old, new, whatever it is, whatever I can find or I'm comfortable with, I'll be able to share with you. And I'll directly jump into the process of encryption. And I was not actually aware that Locky was behaving like this because I did not analyze Locky before. I've analyzed other ransomware samples which did not behave like this, or maybe the C2 servers were available at that point of time. So, anyway, I'm really sorry it did not work that way, but we'll come up with next video where we'll be actually analyzing a ransomware and which will be encrypting the samples, and we'll directly jump with the encryption of samples only to see how it is performing that. So, thank you so much for supporting me. Please like, share, and subscribe to my channel, and I'll see you in the next video.